What's up, everybody? Welcome to the channel. Today we're going to be talking about MongoDB Atlas Vector Search. Build smart apps with Gen AI. Generative AI. So what is Atlas Vector Search? I guess I'll just read this. Integrate your operational database and vector search in a single unified and fully managed platform with a MongoDB native interface that can leverage large language models through popular frameworks. So let me talk about like vector search. And what are vectors? So vectors are a concept that has become pretty popular in the AI space for a while now, but now they're popular where you get an amazing, super popular database like MongoDB building first-class support for them, which is super cool. Because before, there were specialized vector databases out there, like PineConeDB. But now, MongoDB, we can have vector search within our already pre-existing database of MongoDB, which is pretty cool. So, a vector, what is a vector? Okay. A vector is basically a mathematical representation of something, okay, within a multi-dimensional space, essentially. And we're used to looking at the world in 3 dimensions, of course. And so you have like a vector of like, where is, one of those doors behind me? I can imagine where it is in 3D space. But how do you compare things like, so where is that door relation to me? Those are like, we got 3D vectors to kind of describe some of that. But how would you compare like, oh, how similar is Blade Runner, okay, to The Crow? All right, 2 movies. From the like 80s, 90s, their remakes. They're doing a remake of The Crow, but anyways, so I was like, how do you compare something like movies? How do you compare something like automobiles, where there are so many different aspects of these things? Or how do you compare to paragraphs or to words, right? Like, what is the space that those are in? Well, it's not really 3-dimensional space. It's many more than that dimensions, and so you have to have vectors to represent these different things. And so you can take, with MongoDB Vector Search, you can take items in your database, documents rather, and you can generate an embedding for them. And so what is the embedding? Basically, that is an embedding of the vectors to represent something. You could have in your database, a database of vehicles. You could have a database of celebrities. I'm trying to think of some other different examples. You could have a database of animals, okay? And to create the vector of the animal, you might pass in a descriptive paragraph of them, or you might pass in, there are a bunch of different features about them. And then with natural language processing, we can generate an embedding of that text that you provided. At least that's how it's done with, for instance, OpenAI, which we'll be using in this video. Okay, so I think that's a good bit about vectors and my understanding. And a little background as well is this is really cool to me because I actually tried to build like a recommendation engine using vectors a long time ago. And like in 2018, 2019, and back then, the tooling was not like today, and I had to look at like some Python code on how to basically like download a giant like corpus of text and create the model that will generate word vectors and compare different words. So, now, when you have tools like OpenAI and MongoDB Vector Search, and you have those open LLMs like Ollama and others, it's really cool time. So just a little bit of background on me. like now it's so much easier to do this. So this is gonna be really cool. Well, let's get into it. So I've got some Go, and that's the other part. This is Vector Search, MongoDB, and Golang. If you saw the title of the video, you would know that, or the thumbnail. So what I've got here is a project that is actually also, it's got Azure functions. Okay, like this guy keeps adding layers. All right, so these are Azure functions that run. What I want to have is Azure functions that will generate embeddings for a certain document in my database, and that's what this is. And this also is cool because these are Golang Azure functions that I have set up to run with any kind of custom Azure function handler or function type trigger, and that's why I've got a timer trigger here with a schedule. And just so you know, Azure does not support that out of the box. You got to do some special stuff. I got a different video for that, so I'll try to drop the link in the description. Now we've got our Azure functions, and I've got a timer trigger that's going to run periodically, and so the function for that one is basically going to generate an embedding, and I want to walk you through that. So we run the function, we connect to MongoDB, perfect. You always got to disconnect in the defer to make sure you disconnect your connection. Don't want a bunch of dangling connections making you sad. And then you get the database of your choosing. So I have a database referred to as the GIFs database. So basically what we're trying to do is, like, we've got people who want to buy gifts for somebody, and we want to be able to provide them recommendations based on some input. So I also have some code organized here with like a service kind of model. Anyways, so I've got this product service, and I've got a method on that to get the top products in my database. So we're going to be doing embeddings for products, and I get the top products that don't have an embedding. So just trust that that's what this function does, and as long as it works right, which so far it has, we'll be good to go. Then you've got to set up your however you're going to generate the embeddings. I'm using OpenAI. It's just so simple. I would like to use one of those open models, but that's for another day. And then we loop through our products, our product documents. We generate the embedding with the description and the title of the document. So we're going to see how that goes. And then we store it on each document and update that product with the product service, and that's giving us that Mongo result. And yeah, basically at the end we log. And so I have ran this. As you can kind of see, some of the logs are a little goofy because there's actually no upserted ID. I should have made this like, I don't know, match count or something to show how many products are updating. But we've ran this already on a number of products, so what I'll do next is dive into the database that I've got, and we can look at some of those documents and the embeddings. Okay guys, well, here we are in my database, gifs.products. Now we will look for I set a field in here, and if you want to know a little bit more about Go and MongoDB, I've got this product. Let's see, go to the type definition here. This is my product struct. It's got some different things in it, and one of those I've added is an embedding, and it's a slice of float 32s, and you can think of that because it's almost like a matrix of floats to represent this vector embedding. Okay, so without further ado, let's look at the embeddings. I'm just going to look for embedding, or actually that might not work. What about embedding? Aha, we've got many. Great. We should get a lot. So I think the embeddings are a pretty big doc, so that's why, or rather field for the document, or I guess you could call it a document. Yeah, so look at this. An array of 1536 in length, and it just keeps on going. So this is what I was generating with OpenAI when I said, hey, I want you to create an embedding for this amaretto flavored decaf coffee, which I guess is something cool. And we want to, pass in the title and the description. And then OpenAI is saying, okay, well, this is how I'm thinking, based on my language model, like, this is how I see that sucker. So that is how the vector is stored. Now we've got a purifying cleanser, Tata Harper purifying cleanser. So we've got other embeddings for that, but of course they're all going to be the same length because it's like these products are in the same sort of space to exist, and so the same number of dimensions. So this one is going to be different than the other one. We're assuming that hopefully they don't that our vector search doesn't think that these are similar. Okay, so that's a couple examples of the embeddings. So what I want to do next is show creating the index to get these embeddings. And I think I actually created one already, so let's just look at that. Okay, we have our vector search embedding. Let's take a look. It's very generically named vector index, but I passed in the number of dimensions as 1,000. I wanted a good number of dimensions for the index, and I'm not sure though if this is going to align with the embeddings I've stored. So, part of this video we'll be troubleshooting together. I put together a lot of the pieces, but not them all. I've said what the path is. We're going to use this Euclidean similarity. There's a couple different options you can choose from. I think this is the simplest, so I figured we start with this one. And then we have the type of vector. Okay, so now on to the next thing is we've got an API here that, let's see if I can pull it up. Okay, so I've had this code base with this Golang API for a little bit that we can use basically to test out our vector search index. So we have this product/similarity search endpoint that should be a get, so change that. And now if we go, something's unhappy. Go mod tidy. Inconsistent vendoring detected. Holy smokes. Alright, had to fix some technical difficulties there. So we've got our endpoint. We can look at our get products path here to see how we're going to use the vector search. So what I decided to do is take in a text parameter as well and or a product parameter that we'll look at later. And what we want to do here is, okay, so if we pass in text, we're just doing like a natural language query for this vector search. And we will create an embedding from that, and then we'll call get products with vector search on our services package. So I'll show you what that looks like. And it's basically an aggregation pipeline. We grab that collection that we're looking at, and then we build our pipeline using the vector search key and the $ vector search, and then we pass it in like this. That's the way I've got it right now, although I'm gonna have to change this for our video to vector index. I might have to fix that up later. Okay, so got that looking pretty good. Let's see here. Let me close out a lot of that. And now, got this. Okay, so I think what we can do now is test out the API and see how it goes. I should be able to run this locally. One moment. Alright, so we've got our VS Code ready to roll. So I'm going to hit F5 to launch the debugger for our API. And now we're going to open up Postman and mess around with the API and see what we get. And again, I haven't made to see this if this works. I haven't made sure it works. It's in the video. We will live troubleshoot it. Okay. Or semi-live. Obviously, this is recorded. So make sure I got the right endpoint. Let me pop open the main and product/similarity search. I do not have it. That is not what I have. All right. Cool. Okay, so we've got that, and like I said, oof. All right, guys, just want to change something so that this would run unauthenticated, so none of you troublemakers out there try to hoover up my API key. And now we will say, okay, we got our text parameter. We talked about that. And how about we search for like vanilla chocolate? That's how about chocolate candy bar? Kind of see what we get with that. And we'll see. Maybe something could be very wrong here. I'll say that something could be very wrong. Oops. So we'll see how that goes. So it's running. Everything's good. And just want to make sure that I'm using the correct, text. Okay. I wonder how that'll come through though. 4.1 unauthorized. Okay, now it's really going to work. I'm just messing with my authorization. That is all I had to do. No important information for the viewer there. And we're sending the request. Oh, yeah, we got this here. Let me pop that out. And we still got 4.1 unauthorized. Okay, guys, so now we should be getting to a point where things are working. Oh, socket hang up. So everything's kind of, we error out and then we just kind of, we bail. Let's see. Based on field vector search, query vector.0 is the wrong type array, expected type double. All right, let's take a look at this issue within the Atlas world and figure out why this is not really working out. Let's look at some docs. Go into the tutorial. Oh God, come on. Okay guys, so I have a theory on what is not working. First, I saw a little something in the docs here about number dimensions 1536. If you remember from earlier, that's the same length as my arrays. So I updated that to 1536. Then we're getting 2 embeddings back from this. So, but we can pass it an array of strings. I'm thinking what it's actually doing is it's sending me an embedding for the description and then an embedding for the title. So what I'm going to do is I'm going to say I'm just going to get one for the description, and we'll say that that's going to be good enough. And then I'm going to grab the first element, if length embedding, equals 0, then you wouldn't really want to do log fatal everywhere in your Go code, just FYI. One day I'll clean this up. Better to return an error as a value and then handle it at the top level. Okay, enough about that. So embedding. Right, so this is where this is wrong O. So we actually want to drop that and do it like that. And then let's see if we can update this by running a little local test to debug it and get that test to just do our dirty work here. So we'll assign it here, and then will we get a happy face or a sad face? We got a happy face because we say we matched 1. Cool. All right, so now I'm going to let this run for a bit, and then once it's done, as you can see, it's just be cool to log like the title of the product. Maybe we should do that if we do this again. But for now, we're just updating all those products. All right, so once they're updated, we'll jump back in and search it again. All right, we're back. We have updated 599 products, and we're ready to jump back into testing. Out of curiosity, let's look at the embeddings now. Yep, we saw this one before. Okay, we still got 2 arrays. The heck is that about? Guys, I don't like that at all. Okay. What's going on here? Oh, you know what? I know exactly what's going on here. Okay. The problem is that we said let's get all the top products that don't have an embedding, and now we need to update the ones that actually have an embedding. So let's drop that part, and then we'll run this again, and we will update some of the bad embeddings that are bad. Okay, guys, so welcome back. A few days after some debugging, and I realized what the issue was. So we were using this type for this, and that meant that we had that error come through where it was saying that the index 0 value was a array instead of a float. And I was initially looking on the embedding generation side over here, where when we were creating the embedding, passing in the first index of our embedding array to get that slice of a float 32 instead of a slice of float 32 slices. I probably needed to do both, right? We probably needed to do this as well. I mean, I think definitely we needed to do this, but as well, I needed to go over here and pass in the right type here, which is this. And then once I did that, everything was happy. So let me fire this up, and let's test out our vector search API. Here I've got some dark chocolate text, so I'm going to query with that and see what kind of products we get back. Cool. We got some dark chocolate. This is the first product. It's called Fruition 100% dark chocolate. The next product is milk chocolate, but you know, chocolate. Then we've got more dark chocolate, like it, and then more dark chocolate. So that's really cool. Let's see what we get if we type in something like rugged outdoor gear. Hopefully we get something cool. Duffel backpack, tear-resistant ballistic nylon, water repellent. This sounds good. Okay, that sounds pretty good. We've tagged it with outdoor adventures, so this must be relevant. Wilderness adventure essential survival kit. Cool. So I feel like the vector search is working really great. You can see the power of the natural language processing here with this this similarity search using the text. What I'll do in another video potentially is maybe wire up the similarity search for a specific product, so we can pull like associated products, and also add some other features maybe to the UI so you guys can see kind of the power of this. And this is so cool to get set up so simply. Again, like I said, back when I did recommendation engines, you know, 4 or 5 or maybe like 6 years ago, there was not tooling like this. Let me tell you, you had to spend a lot of time. So, all right, thanks for watching.